My name is Elenora and I'm a PhD student at the University of Rome-Tre and Montpellier. In my research I focus on large earthquakes in subduction zones. A subduction zone is a region where an oceanic plate dives below another plate. When this happens, the two plates can get locked along the interface so that the downgoing plate will drag the overriding plate with it while it's moving. This results in the buildup of stress, and when this becomes too high, the overriding plate will move back into its original position, resulting in an earthquake. So to better understand where these earthquakes might occur, we need to take a step back and look at the Earth from a distance. With satellites we can observe the Earth's seafloor, which is actually a landscape containing seamounts, ridges, plateaus, but also very smooth areas. So in my research I focus on the relationship between this roughness of the seafloor and the occurrence of subduction earthquakes. The methods that I use are natural data analysis and analog experiments. So now, let's go into the lab and have a look at the experimental setup. So this is where we do our subduction earthquake experiments. Here you see the downgoing plate, on which we can add different types of seafloor roughness to study the effect they have on earthquakes. We create this seafloor by using a 3D printer. From our natural data analysis, we know what can be considered a smooth or a rough seafloor. Here we print one patch of a very rough seafloor, which will then be added to the subduction setup. After the overriding plate has been loaded, it starts to behave in seismic cycles. The blue arrows here show the different parts of the fault that rupture after one another. By tracking these movements, we can study the rupture behavior with respect to the roughness at the interface.